Hello everyone, and welcome to Sampling and the Observability Error. My name is Steve Flanders. I'm a Director of Engineering at Splunk. I've been in the observability and monitoring space for over the last 10 years, working in logging, distributed tracing, and open source technologies, including OpenCensus and OpenTelemetry. If you're interested in learning more about me, go ahead and follow me on Twitter. So today I want to cover a few different aspects. First, just a very quick introduction around what is observability. Then we'll focus in on distributed tracing and how sampling is used with distributed tracing. And then all the different trade-offs depending on the sampling decisions you decide to make for your environment. So first off, what is observability? I like this quote from Barron that talks about how monitoring is telling you how a system works. Usually it's some sort of known thing, maybe it's even a static threshold that you get alerted on, where observability really lets you ask any question that you want about your environment to figure out why it's not working. It's for more of the unknowns. And as you start working more with distributed architectures, more cloud native stacks, this becomes super critical because you don't necessarily know who is calling you or what changes in behavior are going to happen throughout the different services in your environment. Now, if you've heard of observability, you've probably heard of the three pillars of observability, namely logs, metrics, and traces. These different data sources have some similarities and some differences. They all usually have something to do with time, but the way that they're represented are different. For example, logs are typically unstructured, though in more cloud-native environments you're seeing a lot more structured text. And it usually contains some amount of metadata. You usually use this for last mile analysis within your environment. Metrics are more data point driven, again, time series with metadata, and traditionally metrics are used to alert about a problem. Though they're typically more symptoms, because as you look at more distributed architectures, they don't have context and correlation to get you really to root cause. And that's where traces or distributed tracing comes in. Again, time-based end-to-end requests in your environments, and even some amount of metric information. You typically get your red metrics, so request, errors, and duration, again with associated metadata, and this is often used for problem isolation for both availability and performance problems. And we're going to focus primarily on the tracing aspect, because when you hear the word sampling, it's usually traces that you are sampling. To be fair, sampling may apply to other data sources, like in logs you have verbosity, which is kind of a form of sampling. In the case of metrics, it's the granularity of how often you are collecting them or how you actually roll them up and average them. That is a form of sampling. But for today, we're just going to focus on the tracing aspects. Now, I would be remiss not to mention the OpenTelemetry project, given this is a cloud-native open source summit. OpenTelemetry is actually looking to provide infrastructure around instrumentation, data collection, API, end-to-end implementation, basically, all the way just before the backend. So it doesn't provide a backend solution, but it provides a vendor-agnostic way to send to the backend or backends of your choice. Now, I bring this up only because I'll be demoing it a little bit later to show how sampling kind of plays into this world. But if you're interested in learning more about this project, please do take a look at it. Next up, distributed tracing. So what is distributed tracing? I've gone ahead and taken this picture from the Jaeger tracing documentation. Jaeger is an open source project, also part of CNCF, and definitely worth taking a look at. On the left, you basically have an example of an environment where every circle is a microservice, and what you're basically seeing is a call of an end-to-end request throughout the system. So what ends up happening is something hits service A, this generates a piece of context that then gets passed to all subsequent downstream calls. For example, to B, to C, D, and E. How that ends up being represented when it's collected is more of a waterfall view that you see on the right, where A is kind of the end-to-end or root span of the entire transaction. It tells you how long its duration was. Here you can see like B and E, which look more like independent services calling one another. C and D could be, for example, functional level calls within the same microservices-based application. But from this, we can actually extract the red metrics, request, error, and duration. We can also tack on additional metadata. And because we have context and correlation, we can actually identify like where errors are occurring and why they're occurring, which really helps us get to problem isolation a lot faster, which is super critical in microservices-based environments that are typically polyglot, where every service may be owned by a different service owner. And from an on-call perspective, you want to minimize things like alert storms, which would be very impactful to the team. Now let's talk a little bit about sampling. And to do that, I want to talk about the basics. Now, sampling is actually a pretty in-depth topic, but there are some common things that you'll hear regarding sampling, specifically of tracing information. First is the what. You've probably heard of head-based or tail-based sampling. We're actually going to drill into that, what the differences are, and kind of the trade-offs of those decisions. In addition, you have the when. When does the sampling decision actually happen? And depending on the pipeline that you've configured, there are different stages in which it could occur, and I'll explain that more in depth in just a moment. You have the where. So within a trace, you have spans. Within spans, you have services and operations. You may have attributes, which is kind of that metadata or key value pairs. You even have other information like the duration, and you may want to make a sampling decision based on these different pieces of the telemetry data that you're collecting. The how is more of the policy-based way to make a sampling decision. Like, do I want to do it based on some rule or some rate? Do I want to base it on the duration or a probabilistic way? What are the trade-offs of those is something that we'll cover here as well. And then finally, the why. Like, why would you do sampling in the first place? And at the end of the day, it has everything to do with data and the impact that the data has to you or the environment or the price of the solution that you're leveraging on the other end. So let's first drill into head-based sampling. You may remember the service topology breakdown from the Jaeger documentation. Here's the same representation. If you do head-based sampling, what that basically means is you make a sampling decision on the initial request. So if the A service here is the service that's hit first, that's when you're going to decide whether or not to sample that trace. Now, this is very interesting because the trace is not completed, so you don't necessarily know what happens later. Now, in the case of tail-based sampling, you actually wait for the entire end-to-end request to be completed, and then based on the entire request, you then make a sampling decision on whether or not you want to process and store that information. That's the primary difference between head and tail, but there's a lot more nuance that we'll cover in just a little bit. Now, where can you actually make a sampling decision? Well, that depends a lot on the architecture that you've rolled out, but it's not uncommon that you have one or more applications, and those applications are instrumented. So you could go ahead and make a sampling decision in the instrumentation itself. You probably have rolled out some sort of agent. Maybe it actually exists with the application, or it's more of a host-based agent. So you have one per host with multiple applications running on a given host. Again, you could make a sampling decision there. You could have some sort of standalone service or collector or aggregator or proxy. Usually this is like per data center or per region, and you could make a sampling decision there. And then of course the backend, whether you're running your own or you're sending to a third-party SaaS solution, sampling decisions can also be made on the backend. So really anywhere in the entire pipeline, you can go ahead and make a sampling decision. But what you can sample when, well, that kind of matters. You can do head-based sampling pretty much anywhere. But in the case of tail-based sampling, because we actually have to construct the entire trace before making that sampling decision, it's typically at the service or backend level. There's a little bit more nuance. It may be possible to do it in the agent, but in general, you're talking about having a service or a backend that actually collects all this information and makes a decision based on an entire trace. Now, how does tail-based sampling work? So I mentioned you probably want to do this at the service or the backend. So let's say here I again have my topology and I have a service deployed. So I have 3 collectors, satellites, proxies, whatever you want to call them. I have 3 of them in my data center, and they are fronted by a load balancer so that they can all receive the traffic. So let's assume that a request comes into my microservices-based application, A gets hit, and its span gets sent to the first collector. And then B gets hit and it gets sent to the first collector as well. C gets hit, it gets sent to the third collector. D gets hit, it goes to the third. E goes to the second. Now we have some sort of maybe round robin policy based here on the load balancer. So while I have a single request, the spans have actually gone to different collectors. Now this is a problem for tail-based sampling because I need to actually construct the entire end-to-end trace. So what I basically need is trace ID-based routing. Now that's typically pretty hard to do in the load balancer, so most solutions today that offer tail-based sampling will actually handle it at this collector level. What ends up happening is, like collector 2 here would say, hey, I realize that the trace ID is already being stored in number 1. I'm going to actually pass this span I got from E over to number 1. And number 3 would do the exact same thing. So the idea is all the spans for a given trace will appear on the same node, and then that node can then go ahead and make a sampling decision based on the policies and rules that have been defined. Now, as I mentioned, sampling is a rather complex topic. While we covered some of the major themes that may come up, the way that they kind of stitch together, it depends, right? Like probabilistic type rules, you're typically going to see in more of a head-based sampling solution. Adaptive and rule-based things are typically more seen on the tail-based side. Rate limiting may be able to apply to a given service, but may not be applicable to a given operation, so only certain aspects of the span information can be leveraged. And then policies really depend on the service or the back-end capabilities, whether that's a vendor or an open source solution. These vary greatly upon like what is possible from a configuration perspective. And this is really just the tip of the iceberg. There are more nuance here as well. But again, the goal is to focus on the primary themes around sampling to give you a better understanding of the topic. With that, I'd like to jump into trade-offs. So let's start with head-based sampling again. Some of the pros of this approach are it's very easy to configure it and to manage it. In addition, it's great at actually reducing the amount of data that's being sent, which is one of the why reasons of why you do sampling anyway. That happens at the root service-based level. That's where you make the sampling decision. Now, the cons are, well, I didn't actually wait for the entire request to complete, so I don't know if I'm making an educated or a smart sampling decision. I'm just making one very early on. Another very big problem is that if I'm making a sampling decision at the beginning, then I probably won't have accurate red metrics because I'm not looking at all of the calls. I'm not actually collecting all of that data. And the net result is really incomplete observability. Not only have I reduced the data and I probably don't have representative sets for the things that I care about, even my red metrics are not 100% accurate because I'm not analyzing all that data. So in general, I mean, if you can avoid this model, you typically want to. At a minimum, you want to have full fidelity metrics. You have accurate SLIs or red metrics. You have accurate alerts that you're leveraging here. And typically with head-based sampling, you can't do that. Now, there can be some temporary reasons why you might want to enable head-based sampling. Maybe it's controlling the data or cost, but you just need to know that it really can impact your observability and typically is not the solution you want to head down. So let's again use a representation of head-based sampling here. As I mentioned, it gets made at the parent or root level span. So here it would be the A service. Well, what happens if further on I decide I'm not going to sample this given trace, and then when the D service gets called, it actually generates an error? Well, because I made a sampling decision when A was originally called and I decided not to sample, the fact that an error was thrown in D doesn't matter. I've now lost that data. That really impacts my observability. I can't alert on that scenario. Like if someone's on call, they can't actually pull up that trace. That's a huge impact to my ability to ask any question of my system and to really troubleshoot, perform problem isolation. So this is typically not an ideal scenario. Tail-based sampling, on the other side, actually provides full fidelity metrics, and it allows you to reduce the data based on anything available in the telemetry data that you're collecting. So that's very powerful. The cons are that it's typically hard to manage and it can be quite expensive to actually run these collectors. I'm talking about primarily the customer side. Vendors typically have ways of mitigating those cost concerns, but if the expectation is that you need to deploy something on your side to do the tail-based sampling, that can become complex. You're now talking about a distributed systems problem. You have to handle redundancy, what happens if they go down, and it can be expensive to run because 100% of the data needs to be processed, and even network traffic can be pretty extensive because we need to pass around different spans for a given trace to the right endpoint node. Now, at the end of the day, another con that I wrote is that you have to analyze all the data anyway. Like I mentioned, all the compute and potentially network traffic that's involved with that, that's actually the primary cost. So if you already are going to take that hit of sampling all that data, then why are you doing tail-based sampling in the first place? Now, there can be good reasons for it, but it's definitely a question you should ask yourself. So when you're thinking about this, if you have to sample, and we'll talk more about whether you do or not in just a second, tail-based sampling is going to be better than head-based sampling because you now have full fidelity, accurate metrics. You now have flexibility in actually being able to choose what you sample and not. There are some potential cons, but the flexibility and choice here is quite powerful. One thing you do need to consider, though, is you have to factor in both CapEx and OpEx when you're determining the cost of a solution. Running these satellites or collectors on your side, scaling them up, making sure that they're upgraded and handling the network traffic that's associated with them, that's all part of the cost of leveraging whatever solution that you are. And then one final thing, I didn't write this as a con, but most tail-based solutions don't really have enterprise-y features like encryption between the satellites or some sort of dispatch queue. It's usually all in memory. This isn't necessarily a big deal. It comes down to really business requirements. Like a lot of people don't treat tracing data as containing much or any PII. It's not necessarily the end of the world if you lose that data. Like it's not ideal if you're having an incident or an outage, but at other times, maybe it's not as critical if some of that data is lost. Just something to keep in mind when you're actually evaluating these solutions as well. So let's again go back to the tail-based sampling example and how it works. As I mentioned, there are a few different considerations here. So let's assume that I have my end-to-end app deployed in, I'm in AWS, so I'm in a single region, and it's going to be deployed in multiple availability zones, AZs, because I want to have high availability in case an AZ goes down. So these satellites may be deployed in a single AZ or across multiple for redundancy reasons. Well, the net result there is that if I'm going across AZs, I need to pay for that network traffic. Both my services contacting the right node, depending on how load balancing is configured, as well as the nodes talking to each other to do the trace ID based routing. That incurs a cost. It's even more complex if I actually have an end-to-end request that spans multiple different regions, and there are valid use cases for that. In that case, I might have my services in region 1 and region 2. Well, I have to have this set of satellites in a single region. Doesn't matter if it's in 1, 2, or even 3, but all the traffic needs to go to a single region so that I can actually collect a single trace end-to-end. Well, that map now means I might have cross-region traffic network-wise that I need to pay for as well. And then, as I mentioned earlier, at the end of the day, it's really all the overhead of all the traffic needs to be able to be processed by these satellites. The amount of compute power, memory that this requires can be extensive. Depending on the solutions that are available, there may even be disk related as well. That is a cost of leveraging a tail-based sampling solution. So now let's go back to the why. Why would you sample in the first place? And these are some of the common reasons that come up. One of the biggest is just that scaling is hard. Like, we're not talking about a small amount of data here. Distributed tracing information is typically significantly more than metrics, and it's usually on par with logs, maybe a little less, in some cases maybe a little more, but it's pretty extensive. And so the backend required to actually process and store this information is quite a bit. And then the front end to be able to query it and display it quickly, that's also a hard problem. It's a big data problem. Now this really comes down to, are you rolling your own? Like, do you have your own backend? Is it open source? Have you built built something custom and you're just trying to scale it, is that actually your core IP? Is that where you want to be investing your efforts? Are you going to buy instead into a vendor solution? What do they offer, right? That there's trade-offs to the decision. The next point is just around, not all data is equal. Like, if I have a trace that contains an error, that's probably much more valuable than a trace that does not contain an error. Same applies with things like duration. Like, if I have an outlier, if I'm like above my P90 or P95 or even P99, I probably want to keep that data. I want to understand why. I want to have more samples of that versus if they're all the same exact average duration. Do I really need every one? Sure, I need them from a metrics perspective, but do I need the individual traces? And then maybe like I want production to not sample, I want development to sample heavily, just from a cost perspective and from an availability. Like if dev is down, maybe it's not the end of the world in my environment. Again, this comes down to business requirements and the problems you're trying to solve. But really the biggest reason that comes up around sampling is cost. And when you think of cost, you need to think of many things: the processing aspects, the network egress costs, the storage costs of containing all that data and storing it for whatever retention period you care about, the whole run it versus buy it. Like, are you rolling your own backend? Are you rolling your own solution to instrumentation? Or are you leveraging open source? Are you doing some open source and some vendor? And then finally, the cost of downtime. Like, if I sample and I don't have the data that I need, if I don't have the observability, if I can't answer the questions I need to, what does that cost to my business? And am I willing to actually pay that? So there's a lot of trade-offs and decisions, but this is why sampling is a real thing in distributed tracing. Now, I want to kind of warn about the marketing hype. And now, full disclosure, I work for a vendor, so this applies just as much to the company I work for as any other vendor out there, any other marketing people out there. But you need to be aware of some things when it comes to sampling. Like, you'll hear sampling is fine because like you have all the data for real-time investigation. Well, what does that mean? It usually means you have it for a very small window of time. We're talking minutes, maybe 5 minutes, maybe 15 max. Sure, that's great, but what do you do after the fact? Or, we're going to get all the most interesting things for you. How do I know? How do I trust and verify that? How do I tweak that? What if I need something else that I think is interesting? Is that okay? Again, it comes down to business requirements. Another one is just around like you have to sample because it's just too much data. A lot of this comes out of like the Dapper paper that came from Google, but one of the things you should ask is like, am I working at a FANG company where there is just so much data that I absolutely have to do something about it? Most of us are not in that category. And even at millions of spans per second, it's not as much of a problem as you might think. Now, eventually you will hit some threshold where you need to start considering it, but not every company out there is a Google company, so you need to take that with a grain of salt as well. Are you going to manage your own observability backend? Are you going to use open source? Are you going to use a vendor solution? All of that kind of dictates the amount of data that you can collect and, of course, the costs associated with that. And then finally, like, what have you done to instrument your applications? And if it is so verbose, if you do have so much traffic, why? What problems are you trying to solve? Is that necessary? Did you instrument too much? Do you have too much metadata? Like, is the instrumentation that you provided valuable or not? Because that might be a better problem to go solve than whether or not you sample the data. And then finally, just around, hey, our solution's cheaper because typically of sampling. Again, you have to look at the whole ownership thing. Tail-based sampling doesn't come for free. That cost comes from somewhere. Either it's on your end or it's on the vendor end, but there is a cost associated with it. If you sample, you're going to lose some amount of observability. How much is acceptable? Typically head-based without the full fidelity metrics, that's not going to be good enough for most environments, but tail-based sampling where I may not have every trace, but I do have fully accurate metrics and SLIs, usually that is sufficient. And then are your specific business requirements and desired outcomes being met? At the end of the day, that's really the most important thing. Now with that, I want to give a quick demo. I will actually use the OpenTelemetry project to do this. I'm actually going to fire up a Docker Compose here, and I will walk you through what it's doing as it starts running. So what we basically have is an open telemetry collector. And in that open telemetry collector, we are going to point to 3 different Jaeger instances. So Jaeger is a distributed tracing backend. And what I've done is I've configured 3 different pipelines in the open telemetry collector. So basically, we're going to receive 100% of the traffic, and we are going to send it to a Jaeger instance. We are going to use a probabilistic sampler and send a subset of that traffic to a second Jaeger instance. And then we're going to leverage tail-based sampling, and we're going to send it to a third instance. So this will kind of show you the pros and cons of the different approaches. Now, from a configuration perspective, the probabilistic sampler, the head-based sampling, is configured to sample 1% of the traffic. Again, this is customizable. So I could say 5%, I could say 0.1%, I could say 50%. It's really configurable to your needs. Tail-based sampling, what we're going to do is we're going to tell it that we have a couple policies. One is if it contains an attribute of error equals true, then we're going to sample it. And the next one is if we have an HTTP status code that is between 400 and 599, again, we are going to sample it. So this gives me kind of choice. These are just some examples. You might have different rules or policies or different sampling things that you want to leverage. This me configured to meet your needs, but hopefully this will give you an idea of how it actually works in practice. Now, on the flip side, I mentioned this is a Docker Compose file. So we have 3 Jaeger instances running. We have an OpenTelemetry collector running, and then we basically have a load generator that's passing traffic to the collector. That's basically everything here. This is based on the OpenTelemetry collector demo that's in the GitHub repository today. So let's go ahead and fire up the Jaeger instance that's receiving all of the traffic. So I'll just pick one of the services, and you'll see that there's traffic coming in here. The cart service is the one that I'm looking at particularly. So tons of traces are coming in. That's great. We'll pick the second one here. This is doing probabilistic sampling. So again, I'll pick the cart service, and you'll see there's actually less traces, significantly less, and that's because we're only sampling 1% of them. And then the final one, this is the tail-based sampling that is only capturing errors. So in this case, you'll see, again, cart service, only cart service traces that contain errors are showing up. You won't see any spans or traces that contain non-errors because that wouldn't meet the tail-based sampling rule. So again, 3 different ways of collecting: no sampling, error-based sampling, probabilistic sampling at a 1% rate. Very easy to get started, very easy to kind of configure in your environment, and then you can solve more of the scale problems or the different policies that you care about, the rules that you want to write for making these sampling decisions. So some key takeaways from this presentation. One is definitely understand your business requirements and the desired outcomes. Every environment's a little bit different. What are you trying to solve for? What are the pain points that you have? What visibility and observability do you really need? Second, understand your sampling options, understand their impact to both cost and observability, and compare that against your business requirements and desired outcomes, and decide what is right for you. And then finally, beware of the marketing hype. There's a lot of information out there. It can be hard to kind of navigate all the noise. There's also like traditional more solutions versus cloud native solutions, and the thought processes are a little bit different. Do your own research. And again, the foundation should be your business requirements and desired outcomes and what you're trying to solve for, what you're trying to optimize for. And do you actually get the insights that you need to ensure that your service, your business is successful at the end of the day? And with that, thank you so much for joining me. This is really just an introduction to different types of sampling things that you're going to come across specifically for distributed tracing. I would love to talk to folks more about it. Feel free to reach out to me directly. And thanks so much for joining.
Okay. Thank you, Steve. Thank you for your sharing and your slides. It's very nice and helpful. And it's our Q&A online time. Let's welcome Steve. Hi, Steve. Open your mic.
Hi, how are you?
Okay, hey, how are you? It's our online Q&A time. And let's check out the checkbox. We got 3 questions for you.
Yeah.
So please
Yeah, go ahead. So the first one is, will cloud native observability be a topic that will have like a training course and certification?
Yeah.
I think long term that wouldn't be too surprising. In fact, right now in the CNCF, they actually started a SIG or special interest group on observability, and some of these topics are being discussed, like what is the best way to start promoting and getting more educated about observability. Some of the initial thoughts are around more blogs and just other ways of getting material around observability. But long term, sure, like this is an important topic. A lot of the projects in CNCF are observability based, Jaeger being a big one, Fluent Bits in there. So yeah, I think long term that'll happen. I'm not aware of any immediate plans for that though.
Okay.
Next question, your recommendation to end users that want to build their own solutions for observability. Yeah, so start with CNCF or start with open source projects. There's some good stuff out there. Like Jaeger is a very, very scalable product, very easy to get started. They actually have decoupled the architecture very well, so it's easy to scale up individual components as the amount of data that you're collecting increases, and they can support more streaming-based systems if you need it. From a logging perspective, Fluent Bit is also very efficient at collecting this data. It has rich parsing rules to actually get the data in the format that you care about. Prometheus, again, great metricing tool to collect in more cloud native environments, very common, becoming kind of the standard way to collect metrics today compared to other mechanisms. So you can definitely start with the open source tools, and then you'll probably start building on top of them. Like, hey, I have Prometheus and now I want to have high availability, or I want to scale this to a significant, very large scale. How do I do that? And again, there are open source solutions out there to get you started. So from a getting started perspective, it's really easy. If you're looking for a single tool that provides all the different data sources and a way to kind of query against them, that's not as common today. And as you get to more like enterprise features, like I care about massive scale, or I care about end-to-end encryption, or I care about very rich PII or personally identifying information being extracted, that can be a little bit harder, but there are solutions out there for both open source and commercial, depending on your needs. And then final one is around Istio and asking if, is there any solution to get end-to-end request training working without span context propagation, as this will make it easier and motivate more customers to kind of take advantage of this, or more end users to take advantage of this. Yes, let me break this down for people that are not aware. So Istio is a service mesh. Basically, how it works is you deploy proxies to every one of your applications, and all of your traffic between applications get routed across these proxies. So because there's a proxy in between, you can actually inspect that traffic. And as a result, one common question is, well, hey, if I'm inspecting this traffic anyway, can I get my distributed tracing information from that inspected traffic? And the answer is, of course, yes, you definitely can. Now, I need to take a step back to answer the question. With distributed tracing, it works via something called context propagation. I talked about this a little bit in the presentation. Basically, if I'm thinking about like RPC or remote protocol like type things, like let's think of RESTful services. It basically means I need to pass headers across each one of my requests. So for example, the trace ID, I have to pass that to every single call I make over the network. Well, what happens if my application doesn't actually accept or pass these headers? Well, then context propagation is broken, and as a result, my distributed tracing is broken. That's a problem. So while Istio or any service mesh can provide traffic about everything, can provide trace information about everything that passes through the proxy, it can't guarantee that the headers that are being passed through the proxy, that the application actually accepts and propagates to its downstream calls. So unfortunately, the answer is no. There is no easy way. Yes, you can get some rich information from these proxies, but if you really want to take advantage of distributed tracing, you need to have context propagation. In fact, if anyone is getting started with observability, don't start with a logging tool or a metric tool or a tracing tool. Start with context propagation, because that alone enables so much for you in your environment to be able to troubleshoot availability as well as performance problems. Next question is, Google's Hipster is not supporting OpenTelemetry. Is there any way to get the Hipster demo? Okay. So yeah, so OpenTelemetry is the joining of two different projects, Open Tracing and Open Census. OpenCensus had something called the hipster demo application. So it's basically a polyglot microservices application that was instrumented with OpenCensus, and it was used as a demo environment to kind of show off the power of OpenCensus. We are actually using it for OpenTelemetry as well. So OpenTelemetry merges OpenCensus and OpenTracing together. It actually supports the OpenCensus format. So the fact that the hipster demo app is sending OpenCensus is totally fine. Now, I'm assuming the question is just around, well, hey, it doesn't support OpenTelemetry's format, which is called OTLP. And that's true, it doesn't. And the reason for that is because OTLP was just finalized less than a month ago. So it's very new. And we were waiting for the tracing spec to become finalized and waiting for the OTLP protocol to the first version of it to be rolled out. That's now done. So I think you'll actually see the hipster demo app be instrumented with OpenTelemetry going forward, but there's no reason why you can't use it with the OpenTelemetry project today, because the OpenTelemetry project does support OpenCensus. So if you have the collector, for example, you can receive and export OpenCensus format. So the same demo application can be used. I know that I still use the hipster demo app today when I'm showing off OpenTelemetry. There's also a question about how do you get this tracing hipster demo application. I don't have the link readily available, but I'm pretty sure if you just go Google the Google microservices demo application, it's on GitHub. I think if you just do Google hipster microservices, you'll probably find it. But on GitHub, there is a repository that basically lists many different microservices. It shows off all the primary languages. So you have like .NET, Java, JavaScript, Python. I don't remember all the other ones, but the idea here is that you can test what the instrumentation looks like because the instrumentation is language specific, and you can see an end-to-end request calling through these different languages and what that would actually look like in the backend or backends of your choice. So I think that addresses most of the primary questions in the live Q&A here.
Okay, is any other questions for our attendees? Okay, I think it's no more. Okay, thank you, Steve. Thank you so much. I love your slide, by the way. Thank you.
Thanks so much for having me.
Thank you. Thank you. Bye.
Bye.